How do self-organizing maps, SOMs, work? Imagine you have a huge pile of data points, and you want to see how they relate to each other without labels or categories. That's where self-organizing maps come into play. They are a special kind of neural network used for sorting and visualizing complex data. They help us understand patterns by turning high-dimensional data into a simple two-dimensional map. This makes it easier to spot clusters or groups in the data. The process starts with a grid of nodes, which are like tiny computers called neurons. Each neuron has a weight vector, which is a set of numbers matching the data's features. These nodes are arranged in a fixed pattern, often in a rectangle or hexagon shape. Think of it like a chessboard or honeycomb. Training a self-organizing map involves a few key steps. First, the weights of all the nodes are set to small random values. Then, a data point from the dataset is picked at random and shown to the map. The next step is to find the node whose weight vector is closest to that data point. This node is called the best matching unit, or BMU. It's like the neuron that best represents that piece of data. Once the BMU is found, the map updates. The BMU and its neighboring nodes change their weights to become more like the input data. This adjustment is controlled by a learning rate, which determines how much the weights change, and a neighborhood function, which decides how far the updates spread. Over time, the neighborhood shrinks, so only the closest nodes are affected. This process repeats many times, gradually making the map more organized. As the training continues, similar data points activate nodes that are close together on the grid. The map learns to preserve the topological relationships of the original data, meaning points that are similar stay near each other. This helps us see the structure and clusters within complex datasets. Self-organizing maps are used for visualizing data, finding groups, detecting anomalies, and extracting features. They are especially useful when working with data that has many features, making it hard to visualize directly. Unlike supervised learning models that need labeled data, self-organizing maps learn from the data itself, revealing hidden patterns without any labels. In the world of artificial intelligence, SOMs show how unsupervised learning can uncover structures in data without guidance. They are different from models like ChatGPT or image generators, which learn from labeled examples. SOMs organize data in a way that makes it easier to analyze and understand. Using SOMs responsibly is important, especially when dealing with sensitive information. They should be used to find meaningful patterns without bias or misinterpretation. In relation to tools like ChatGPT, DALL-E, or Midjourney, SOMs can help organize data that can improve how these models generate content or personalize experiences. They can also be part of productivity tools that group user preferences or behaviors to make interactions smoother. Overall, self-organizing maps are a powerful way to make sense of complex data. They turn high-dimensional information into simple, visual maps that help us see the relationships and structures hidden within the data.